My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with a Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. This is episode number 52 of the 120 Days to Jamb Mathematics with Flash Isaac. In this episode, we shall be looking at questions under matrices and determinants. And from now to episode number 56, we shall be solving matrices questions. And don't forget, Jamb expects you to know algebra of matrices not exceeding 3 by 3. Determinants of matrices not exceeding 3 by 3. And inverse of matrices not exceeding 2 by 2. In fact, inverse of 2 by 2 matrices precisely. Now, the first question before us is, if the matrix P is equals this and matrix Q is equals that, find 2P plus Q. This is scalar multiplication of matrices and also addition of matrices. We are looking for 2 times P, then we add it to Q. 2 times P is simply 2 times 5, 3, 2, 1. This is a 2 by 2 matrix. To multiply a matrix with a single number, if I give you a single number and I say use this single number to multiply a matrix, what you simply do is use the number to multiply the elements of the matrix one by one. To have 2 times 5, 10, then 2 times 3, 6, 2 times 2, 4, 2 times 1, 2. So 2P is therefore equals 10, 6, 4, and 2. Nothing more, nothing less. But that is not the final answer, and that is not what we are told to do. The question says, find 2P plus Q. This is now 2P, 10, 6, 4, and 2. Let's add Q to 2P. Meanwhile, Q is already 4, 2, 3, and 5. The matrices, they have the same number of rows and the same number of columns. Therefore, addition is possible. How do we add matrices? Like I said in the last episode, you add the corresponding elements. This guy and this guy, they are standing in similar position. This guy and this guy, they are in similar position. 6 and 2, they are in similar position. 4 and 3, they are in similar position. What is the position of 6? 6 is in row 1, column 2. The first row, the second column, that is the position of 6. 2 is also in the first row and second column. The ones that are similar, you add them. We therefore say 10 plus 4, 10 plus 4, 6 plus 2, 6 plus 2, 4 plus 3, 4 plus 3, 2 plus 5, 2 plus 5. So this will give you 10 plus 4 is 14, 6 plus 2, 6, 7 is 8, 4 plus 3 is 7, 2 plus 5 is also 7. So the answer is 14, 8, 7, 7. Let's see if there's any option like that. Looking at all the options, option A seems to be the correct option, and that is the correct option. Let's look at the next question. We are given two matrices, M and N, and we are asked to find 2M minus 3N. This is algebra of matrices. And don't forget, the first matrix is M, the second is N. They did not say M minus N, no. They said 2M minus 3N, which means the matrix M, multiply it by 2 to have something like this. 1, 3, 2, 4, 5, minus 1, minus 3, 2, 0. Minus 3N, multiply N by 3 to have 1 minus 2, 3, 4 minus 1, 5, 2 minus 3 minus 1. To multiply a matrix by a single number, irrespective of whether it is 3 by 3, 2 by 2, whatever, the same law applies. You use the single number to multiply each of the matrices. In this case, 2 times this guy will be 2 times 1, 2, 2 times 3, 6, 2 times 2, 4, 2 times 4, 8, 2 times 5, 10, 2 times minus 1, minus 2, 2 times minus 3, minus 6, 2 times 2, 4, 2 times 0 is 0, minus 3 times 1, 3, 3 times minus 2, minus 6, 3 times 3, 9, 3 times 4, 12, 3 times minus 1, minus 3, 3 times 5, 15, 3 times 2, 6, 3 times minus 3 is minus 9, and 3 times minus 1 is minus 3. From here, this is 2M and this is 3N. So the way we subtract matrices is also the way we add matrices. While adding the matrices earlier, we said add the corresponding element, meaning 2 and 3 here, they are in the same position, you add. 6 and minus 6 are in the same position, you add. That is how we also do for subtraction. You subtract the ones that are in similar position. Here, 2 and 3 are in the same position. This and this same position. And this is actually easy because you cannot add matrices when they are the same dimension. They must have the same rows and the same column so that the ones standing in similar position will be operated. For example, 0 here and minus 3 are in similar position. You subtract them. Now let's get back to business. 2 minus 3 is minus 1. 6 minus 6 is 12. Minus 6 is plus 6. So 6 minus 6 is 6 plus 6. That is 12. 4 minus 9 minus 5. 8 minus 12, that is minus 4. 10 minus 3, that is 13. Minus 2 minus 15, that is minus 17. Minus 6 minus 6, that is minus 12. 4 minus 9, that is 4 plus 9, 13. 0 minus 3, that is 0 plus 3, that is 3. So the matrix is therefore minus 1, 12, minus 5, minus 4, 13, minus 17, minus 12, 13, and 3. So ladies and gentlemen, this is the answer to this question. And this brings us to the end of this episode. I hope you found this interesting. See you in the next episode. And don't forget to subscribe to this channel if you've not done that. get the Flash Learners application and begin to play with further questions. See ya!